discussion and news from the coq development team. So we will start with about 15 minutes talk by Enrico, Tassi, and Matthieu Sozeau. And after that, we will have a longer Q&A session. So as usual, raise your hand on Zoom and you will be able to ask questions whenever you want.
Thank you. So yes, this is a coq development team session. So it's going to start with a few notes from the release manager of CoqPL, Enrico Tassi. Then I talk about the new features in that version, features that are in the works in the system, and then we'll do a traditional Q&A. Let's go and go.
Yes, another way to put it, I talk about the nasty stuff, then Matthieu talks about the cool stuff. So let's begin. So roughly a week ago, Coq 8.13 was released. So now you can start considering switching to the new version. And I will give you some hints on the new things that may have changed behavior or that may be surprising, so that should be easier than to switch. And also we'll talk a little about how the release will happen this time and will happen in the future, because it will change a little. So the first and most important thing is a new warning that was introduced in 8.13 about hints. So most of the commands, the directives that you give to coq, like, I don't know, notations or implicit arguments, are linked to the module that encloses them. So whenever you import such a module, then you activate the notations and the implicit arguments. This is true for most of these directives, but not for hints. Actually, there are two attributes that can be specified to hints. One is the bad one and one is the good one. Unfortunately, the default is the bad one. And the bad one is that hints are active even if you don't import explicitly the module in which they are defined. They become active as soon as you load the library that defines them. And loading libraries, requiring libraries, is transitive. So maybe you use library A and you don't even know that A uses B and B defines a hint, and the hint becomes active. So maybe your proofs depend on a hint that you never requested, okay? And this makes libraries hard to sometimes debug, because you think you use A, but actually it's B that changed and broke your scripts. Okay, so we would like to change the default and saying that hints, as all the other commands, are linked to the enclosing module. But if we change the behavior, it will break all your scripts in a bad way. So we came up with a plan that I'm going to explain so that you can migrate your code without too many troubles, hopefully. So if you compile your library with coq 8.13, some, not all the hints command, but some of them will issue a warning. Okay, so by specifying that these hints have a global effect, you will your hint will behave exactly as before. Okay, so you just silence the warning. Then one by one, you can switch the hint from the global and not so desired effect to a more polite one. That means that the hint is enabled only if you import the module in which it is defined. And then you compile your library and you see where it breaks. And when it breaks, it means that very likely a hint you needed is not explicitly part of a module you imported. So you fix your import line by importing one more file, for example. And then you move on. So you can gradually migrate your code with little breakage every time, so that hopefully you can migrate your entire code without too much pain. And we plan to switch the default to the better behaved the export attribute in a couple of coq releases. Maybe it will take more time because projects will be slower in migrating, but that's our plan. So. And there is a very nice explanation of all this and tutorial on how to migrate your code written by Pierre-Marie that is linked in the release notes of coq 8.13. So this was the most difficult one. Now, notation systems. The notation system got a lot of fixes and improvements. And the main thing that could affect you is how notations are selected. The new algorithm, I cannot really explain the old algorithm, but the new algorithm is easier to explain. So there are two rules. When coq wants to print a term, it has to select which notation to use. And sometimes two notations kind of overlap, okay? And coq will choose now the most specific notation. That means the notation that matches the biggest term. Imagine that you have two notations about the constant that is the order over natural numbers, for example. One notation is the usual infix pointy bracket, and the other one is a notation that fixes 0 on the left-hand side and displays as is positive, okay? So if the term you want to print is less or equal 0, another term, coq will always pick the most specific one, that is the one that should display is positive, because it matches a bigger term. It matches the head symbol, but also the left-hand side, okay? While the usual one only matches the head symbol, and the two arguments are unspecified. And another thing that changes is that sometimes coq cannot choose using this rule, and it rather chooses the one, the notation that was imported the last, okay, the most recently imported notation. And this was not the case before. Before, it was impossible to say, I prefer this notation to that. Well, now, if you import the module, the notations that are in there takes precedence over the other ones. These new rules were designed with power users, and some of them even tested the beta version of coq. It seems to work for them. I'm confident that it's better than the situation we had before, but it's slightly different. So it may cause some breakage in your display. So please test and give us feedback if these rules don't work for you. Yes, a new thing. Since coq 8.5 or maybe 8.6, now I don't remember, coq has three evaluation routines in the type checker. There is the lazy one that is an interpreter to evaluate your lambda terms. Then VM computes, compiles your lambda terms into bytecode, and then there is a virtual machine executing this bytecode. And then there is native compute that uses the OCaml compiler to generate native binary code for your microprocessor so that your lambda terms can be evaluated even faster. Unfortunately, up to this release of coq, it was quite hard to take advantage of native compute because we had to make a choice in the coq packages, so enabling it was not so easy. Then Eric, Martin Dorel, and Pierrot managed to come up with a detailed plan on how to make it easier for users that want to try this evaluation strategy, evaluation routine, to opt in an easy way. So now there is a new empty package called coq-native. If you have it installed, if you opt in, then coq will compile ahead of time all the lambda terms of the libraries you use into native code, so that when you want to compute with these, you can get better performances. It's still an opt-in because there are some little problems. I couldn't, okay, according to my experience, things work pretty smoothly using the OCaml compiler version 407. But people reported that on some versions of the OCaml compiler and on some variants of it, like the F lambda ones, sometimes the memory or the time or the stack space that it's required in order to compile your lambda terms to native code, well, these quantities are huge. Okay, so if you experience one of these problems, well, it's probably tied to the specific OCaml compiler you use. If you go back to 407, I think it will work pretty fine. At least in all my tests, it works nicely. Then I want to advertise this project under the coq organization called the platform. That is a distribution of packages. It's a collection of existing coq packages that we test okay, that we put together, giving them a version, a name, making it somewhat standard collection. And we are trying to make it very easy to install these packages. Concretely, so far the output is are two things: some scripts that install the platform over the main operating systems. Behind the scenes, the platform is based on the OPAM packages you are probably familiar with. But if you run the scripts on Windows, for example, the scripts set up a Cygwin installation so that you can actually run OPAM. If you run them on Mac OS, then it will use Brew or Mac ports to install all the dependencies that are needed for you. So there is some work to make things easier to install. And this is still for developers, people that would like to use Coq to really to develop new libraries and build stuff. For people that just want to try Coq or to use, let's say it in a light way, like students, for example, we are providing binary installers. For Windows, this has been done by Michael Soktrop in the past and is still pretty good. We have a new one for Linux based on Snap, and we are working on one on OS X. It's in the works. I wanted to mention the platform because it will become more relevant, the role of this project, into the release of Coq. Already this time, 8.13 was a sort of transition. For example, as I was saying, the Windows installer for Coq it was built using the platform scripts. And then we have the Linux package again is built using the platform. So in the future, I think we will advertise not really a release of Coq, but a release of the platform that will include the new version of Coq, but also will package, will provide many packages for that versions of Coq that are tested to work. And that should make it easier for you to switch to the new version because many libraries you may need are already there and work. And so especially in the future, but even now for 8.13, I think that if you're a user or a student, you should really look at these installers and or the scripts from the platform in order to play with Coq. If you are a library developer, for example, you teach and you want to give exercises to the students, or you're submitting a paper and you want the reviewers to evaluate your artifact, I think you should test your files against the platform. We are planning to even provide Docker images so that you can easily put in CI a test that runs against the platform. If you are a developer of a package that happens to be in the platform, well, at some point, as it happened in this release cycle, we will ask you to tag a version of your package. We don't want to put in the platform unreleased versions of the software. So this time, I think I contacted 15, maybe 20 projects, asking them to make a tag during the release of 8.13. And I really have to thank you guys because you did a great job. You tagged very quickly, and it was really as it should work. I just want to clarify one aspect that a few projects asked me to clarify this, so I want to do it now. When we ask you to tag your software, maybe Coq is not fully released. There is not a final tag in the Coq repository, but we commit ourselves not to change really Coq. So don't be afraid of releasing a version that will not finally work with the release of Coq. Okay, so we're trying to coordinate these things so that it doesn't happen. And the last thing, if you develop a plugin with ML code, and there were a few talks before using little plugins, for example, if you want your plugin to kind of survive with minimal effort, please put it into the CI of Coq so that we can fix it for you when we modify an API. Okay, these are my recommendations for you. And now I think I will pass the ball to Matthieu for the nice cool stuff of 8.13.
Thank you. So I'm just going to go through all the new features in this version. They are all available in the changes on the release notes for that version. The main two things are this primitive persistent array type, which is another primitive type in addition to unsigned integers and floating point numbers that were added in 8.12. So this can be used to get a compact representation of data. And you have all the usual theory on functional arrays available on that type. Another change that's in the kernel is the addition of the possibility to have uniqueness of identity proofs definitionally for the equality type defined in SPROP. So that provides a more expressive system, but there is a caveat that we don't know about the consistency of this this axiom in presence of impredicativity. So we think it's safe if you are just looking at equalities of natural numbers, for example. But if you are using this irrelevance of equality at higher types, you are in uncharted territory. So there are details about this problem in the release notes. As Enrico has said, there's a lot of improvements of notations that were done, and implicit argument handling. They are printed better, they are handled better when you combine the implicit arguments with notations. So you can reuse the implicit argument status of the thing you put on the right-hand side of a notation declaration transparently. There's been a lot of work on improving the grammar or the many grammars actually that are part of the reference manual, and they are now more consistent with the actual implementation, and we take care that they don't desynchronize. Something that might have some impact on compatibility is that LIA and ZDFI now have been enhanced to support more operators, in particular Boolean operators on the natural numbers, and the new notions of unsigned and signed integers. And finally, one fix to the kernel was an incompleteness bug in the treatment of cumulative inductive types. So if you use polymorphic cumulative inductive types, there are some cases where you could break subject reduction. And that has been fixed only partially, and the full fix will come in 8.14. And of course, along with Coq, there are many plugins that the developers develop on the side. Or inside the repository, even like LTAC, CoqLP, Therapy, Equations, and GSCoq, and many others that all add improvements and that you will be able to enjoy as well. Next slide. So in the pipeline for the next version, a change of the case representation. So currently the representation of cases in Coq assumes that the predicate of a case is a lambda abstraction on the indices of the inductive type and the value in the inductive type that corresponds to the as-in clause in your match statements. And also all the branches of a pattern matching construct are just lambda abstractions and latins corresponding to each constructor. So if your constructor abstracts on a natural number, the branch is represented as a lambda abstraction on a natural number. And we've been changing that in relation in particular to this problem of incompleteness to use a more efficient and closer to the syntax, to the user level syntax notion of representation of the cases, where now we are attached to a case. We have the universe instance on which the case, the inductive, the case is applied to some inductive, which is instantiated by some universe instance and parameters. And now this information is stored at the case node. It was not before. But from that information, we can reconstruct all the types of the predicate and the branches in the match, so they don't need to appear as lambda abstractions anymore. And that's actually what you see when you look at a match printed by Coq. You just see the name in the as and in clauses of the indices and the inductive variable you abstract on. And similarly, in the branches, you never see the branches as the type of the individual arguments of the branches. So now they are matching. And this requires actually, even in MetaCoq, an updated meta theory proof to show that this new representation really does not break anything. In particular, it was fairly complicated to handle Latins that could appear in parameters or indices or arguments of constructors in inductive declarations. So we have double checked that, that this does not introduce new bugs in the kernel this way. There is a lot of work by Enrico, Maxime, and Emilio on reworking the document manager and improving the integration with IDEs. We can maybe talk about this after in the question session. I've been working on this support for inductive types for a long time, and I hope we will have a complete design for 8.14. That's been a work that started during the Coq user and developers meeting a few months back on designing the theory of signed integers, of primitive signed integers on top of the notion of unsigned ones. That's been going well. That should be part of 8.14. And there is an external contribution on size typing. That's an open PR that tries to add a sized typing algorithm to the kernel. That would be an alternative to the syntactic check we have now to check that fixed points and co-fixed points are guarded. There are some difficulties in actually integrating this code, even if it was made to be as compatible as possible with existing system. But it might be there for 8.14. And finally, Hugo is working on improving the small inversion system, the small inversion technique for inverting dependent predicates to be integrated in the pattern matching compilation of Coq. And that might also come in the next version. In the future, well, we have been fairly better now at explaining what's planned in the future using these CEPs, Coq enhancement proposals. Right now on the table are rewrite rules by Theo Winterhalter, which whose goal is to integrate some notion of rewriting to the conversion algorithm of Coq. There is a CEP on adding eta reduction and contravariance of typing to the system to make the system cleaner and easier to explain. In particular, to justify correctly the notion of eta conversion in Coq, we would need this kind of contravariance of typing. There is, as I said before, improved UI support. There was a recent proposal by Jim Ferler to add a visual LTAG debugger. He just recently opened a CEP. If you're interested in that, I encourage you to go and see this and talk about it. And we are planning to redesign the website, which looks a bit 20,000. And that's going to be done by outsourcing. On the longer term, there's work around extending the type theory in multiple directions. Here in Nantes, with the Galinet team, we are looking at sort polymorphism, whose goal is to ultimately subsume at least a template polymorphism to get rid of the template polymorphism feature of Coq. But this notion of sort polymorphism, which would be the ability to have not just a hierarchy of types and propositions and strict propositions, but many other hierarchies of sort, would allow to integrate variants of type theory, like exceptional type theory or setoid type theory in the system. And another direction is to work on integrating the notion of from cubical type theory in the system. Okay. I think that's it. Just a few development news. So, as for a few years now, we've been doing our best to have an open development process and clear guidelines for for developing the system. So we are using these PRs, and we have a big CI infrastructure now, which is kind of a critical size. So we are looking for options to lower the cost of passing CI, which is now critical, especially at release time. We've been helped a lot by the work of Theo Zimmerman, which I want to thank especially for this coq-bot, which allows us to ease the process of reviewing and merging PRs. And finally, I think it opened this year, or maybe what was last year that we opened? No, Zulip was opened this year. So I wanted to mention that we have this Zulip app now, which replaces the Gitter channel, which we use for day-to-day communication. And it's really open to developers and users at any level, in addition to the existing discourse for. Okay. I think that's, thank you. So we'll take questions.
Thank you.
Now.
So we can now start the Q&As. Chantal?
Yes, first, thank you all the developers for this new version of Coq. I'm very happy to see that native arrays are now present in standard Coq. I have a question regarding coq-native. Is the Coq script compatible? Is the Coq script which is compatible with Coq 8.13 also compatible with coq-native and vice versa? And is it also true for plugins that have OPAM code?
I think it should. If it's not the case, then it's a bug, and please report it.
Okay. So the POPL code is very similar. The only difference is the compilation.
Yes. What happens differently is when you compile a .v file, it also compiles the lambda terms that it contains, the definitions, to native code. But the rest should be the same. So if you have a plugin, it shouldn't change. If
Okay.
in theory, it's seamless. It may cost more time and space and stack, whatever, to compile the .v file, and not really to compile the .v file, but to also compile the lambda terms to native code. But all the rest should be the same.
Okay, thank you.
Ralph?
Yes, thanks for that overview. I was wondering about one thing when you mentioned sort polymorphism. So I think I heard previous discussion that universe polymorphism, about, like using that essentially to replace template polymorphism. It seems that didn't work out. But how will universe polymorphism and sort polymorphism, like is one a generalization of the other, or are we going to have two kinds of polymorphism, or is it not clear yet? I mean, how does that work?
Okay, so the idea would be that sort polymorphism is a generalization of universe polymorphism. It's just that sort polymorphism allows you to introduce new sorts that might be impredicative or predicative, so be annotated by levels. And indeed, it subsumes template polymorphism in the sense that if you have universe polymorphism only, for example, for the equality type, you cannot have the equality type be instantiated at the level of a prop. It can only be instantiated at predicative levels. So sort polymorphism would allow you to mix predicative and impredicative hierarchies in general, not just type and prop, but others as well. So,
okay, thanks.
So it might not be apparent why this is a problem. So most of the uses of template polymorphism can already be subsumed by just universe polymorphism. It's just the cases where you're doing a little bit of proof relevant manipulations of equality, which is part of the standard library, for example, where this is a problem.
You said most uses. So does this include list? Because list is one of those types where we run into universe issues fairly regularly.
Yes, yes. So there are other issues related to the inference and the growing number of universes when you use universe polymorphism as it is now. There are also improvements to the sort system, which allows to use algebraic universes everywhere instead of always generating constraints and fresh universes. that should help with that. And of course, there were still some bugs in this cumulative inductive types that were lurking. So mainly the syntactic handling of them in the implementation of coq that I've been ironing out by doing the formalization in MetaCoq. That should disappear and really make lists, I mean polymorphic lists, they are irrelevant in their universe argument. So in principle, you should not see any incompatibility with how lists are used today with template polymorphism.
Okay, but that's still, so that's not blocked on sorted polymorphism, but it's blocked on fixing universe polymorphism. So it's good enough for like being used pervasively the way list is.
Yeah.
Okay.
Xavier? Xavier, you raised your hand?
Yes, I did. Sorry, I couldn't hear you very well. Your sound is awful, Asia.
Okay.
All right,
Sorry
so
about
I
that.
had a question regarding function. So this is kind of an old mechanism in Coq that I still find quite useful to write like recursive functions on well-founded orderings or even complex pattern matchings where you really want to limit the number of cases you have to reason about. So, and I still use function quite a bit in CompCert. Yet with every new release of CompCert, with every new release of Coq, I'm getting new warnings triggered by function generated terms. So I just cannot handle them. And there's an example for 8.13 that has been reported recently by Bernard Schummer. So my question is the following: is function still supported? If yes, please fix the warnings. Okay, terms generated by function should not trigger warnings. And or if not, please tell it, say so, and let's work together on finding proper alternatives.
Don't know if Pierre-Marie is here, who's been the one maintaining function-related code the most.
I may want to say something. I've been looking at questions posed by an intern last summer. I think it was an intern of Xavier's, trying to understand, because I've always had the feeling that the function was out of moral support, at least, even if it's still technically supported. And so I tried to understand whether the code that is written usually with function could be written as well with equations. And I have the impression that what we should try to spend is some time to understand how much of your code could be ported to equations. The one difficulty I had could be solved by using something that's called the inspect pattern, but I don't know who invented that name. Would that help you, Xavier?
I'm certainly open to using equations, but then I would like equations to be part of the standard distribution, which it is not, I think. So right now, I'm not quite sure if equations is mature enough for me to use, or if it is still considered experimental. So I would first need assurance that equations will be supported at least as well as function is supported today. But again, I mean, function keeps working, all right? And if you ignore the warnings, it keeps working, and it's been working for 15 years, so that's pretty good. But still, I would like to know what the plans are, basically.
So maybe I can answer this. So there was a plan to make a function front end for equations, basically, because they implement most of the same features, except for those things that you mentioned about factorizing cases. So for that, we are rather using views in equations. So you have to define yourself an inductive that carves out the cases you want to consider. And there are some, I mean, it's a lot of engineering to just write this translation from coq terms to equations, and I never got around to do that. Right now, our main problem with function is just that the code is hard to maintain, but we've been doing it until now. So until everyone can, I mean, use these equations and try, and nobody relies on function, it will stay around, I think. Pierre-Marie has been kind enough to update and maintain it since a few versions. I don't know exactly about what warning what warning you are mentioning.
Well, I just checked the bug report, and it is a new warning that was introduced to try to catch some errors when you use a default case in a pattern matching that says, well, look, it's fishy. So probably the terms generated behind the scenes by function, maybe they are correct, but they don't disable the warning.
Yeah, I didn't.
So I think it's easy to fix, but well, it was an oversight, I would say, for this specific warning. Then I don't know if there are others.
Yeah, actually, that one should have maybe been in the news because it will affect a lot of people. So if you have a catch-all match taking a variable argument x, and x is actually not used in the right-hand side, now you get a warning, which was not the case before. And you will find that in your code probably in some places. And I guess the auto-generated definitions of function don't pass, don't abide by this warning, but we could just disable it for that. Does that answer your question, Xavier?
Yeah, sort of. I mean, yeah, you could disable the warning. You could ask me to migrate to equations if that's the new standard. I mean, I'm willing to. Well, there are many ways to solve this little problem, but I would like to know what to do. Basically, I'm a little lost at the moment.
Yeah.
Okay.
I would prefer it if you tried equations and report me if something does not lift. That something you could do with function cannot be done with equations. From all the feedback I got was that people were able to adapt their code.
You can consider that function is still maintained, but like OCaml build is still maintained, and equation is the future, like June is the future, if my comparison makes sense. And by the way, regarding distribution, you heard earlier Enrico talk about the platform, and equation is, of course, part of this platform. So if you depend on the platform, then you do have equation.
Chantal has a question. Also, Bas is raising his hand, but not in the usual way.
Raising her hand before Bas.
Yes, but I can let Bas speak because I already asked a question.
Decide the two of you.
I have 3 questions, so maybe that's a bit unfair. I think for Matthieu, so is the denotational semantics of inductive types for coq, or the set theoretic one, understood? So it's quite well worked out for Martin-Löf type theory, but it would be nice to actually know that, say, the work by Bruno Barras on the set theoretic semantics actually extends.
That's a good question. I have no idea. Yeah.
I can give some references, but it's certainly not completely worked out as I think. I think it's possible. It's just it would be good to spell it out.
There are probably interactions with implicativity should be worked out.
Yeah. Similar one, the semantics of the size types. That's again somewhat questionable, I think, at least in Agda, or maybe more questionable. At least in Agda, I don't think they're fully understood denotationally or set theoretically.
Yes. same thing, but here Bruno actually has a.
I'm supposed to say that you should be using guarded types.
In the case of size types, so the implementation was not done by Bruno, so it differs a bit. But if I remember correctly, in the habilitation, he actually considers semantics of size typing. So it should be close enough. And regarding the version that is currently
But that's the operational semantics, isn't it? That's the operational semantics, isn't it? Denotational semantics.
I'm not entirely sure what he's doing with them. But I think there was some denotational semantics there.
Okay, that will be good to check.
Yeah, but regarding the implementation that's been proposed, it's entirely compatible with coq, so you can switch size checking. Actually, it's doing size inference and size checking inside the kernel, so the user does not have to use to add annotations at this point. It's all computed by the system, and it's more restrictive than what the version of size types in Agda, for example, where they have these inconsistency issues because they have first class quantification on sizes, which is which has not been studied formally.
Yeah, and the third one is, can you elaborate on the plans for cubicle type theory?
Not me, but maybe Hugo can.
About cubicle type theory, I don't have extremely concrete plans. So basically, it's to implement a variant of cubicle type theory based on the parametricity translations, the univalent parametricity translations that you can find at level 1 in the paper from Matthieu, Rick Tanter, and Nicolas Tabarot. So it's a generalization of this translation in all dimensions. About the exact, so this is a variant of cubicle type theories and without faces, and with a few more definitional properties for equality in different types, but I'm not clear yet in the exact design, and so I can't tell more currently. So I don't think it will come, at least I don't think it will come in the next year, unless maybe some other people, I don't know, Matthieu or Pierre-Marie are also interested, but I don't think there will be something in the next year at the point of view of implementation.
Thanks. Chantal?
Yes, my question was not truly about coq, but rather about metacoq. But since you mentioned it, I thought I could ask my question. What is the plan for the future of metacoq, and about features that you plan to add, and also about the version of coq you will support, because I think currently it's still based on coq 8.11.
So the plan is to follow the coq implementation. So there will be a release for 8.13 coming up in the next few days. So obviously there's a little issue that when we change representation, like we are doing for 8.14, we need to change the verification of the representation, or we can add some compatibility wrappers there. And the plan is to continue on the meta-theoretic study, or to finish the meta-theoretic study of the system, so to prove confluent for the actual implementation of coq, and that includes handling eta conversion, properly, and that's where it would be a lot easier if Coq had a cleaner handling of eta conversion. So that's the plan of Hugo and myself on eta reduction and contravariance typing. And then there's a lot of work on using MetaCoq to do meta programming plugins, or proving the translations. That's going to continue. I don't have specific goal to share yet.
Okay, thanks.
Okay, it seems we're perfectly on time to end the session. So it's time to thank you all, our participants and presenters and our invited speaker for this virtual meeting. The discussion threads and breakout rooms, I think, will remain open at least for today. And so you can continue discussion, and even the chat channel will remain open, I think, for the whole duration of POPL. So do not hesitate to discuss all this nice stuff we've seen today, and see you next year, hopefully live.
There's now a scheduled event, visit Copenhagen, I think, or something along those lines.
Yes, but you're the local, so maybe you know better.
So we should start speaking Danish now.
Yeah, probably. So this is an